Okay, this is part 5 for the tissues. We ended with epithelial tissue. Now we're going to move on to CT, to connective tissue. So connective tissue is the most abundant. We're going to see it in every single place. And we already know from going over epithelial tissue that CT is found deep to every single bit of epithelial tissue. We can subdivide CT into 4 distinct categories. We have CT proper, we have cartilage, bone, and blood. Keep in mind with the CT proper, we're going to further subdivide that into loose and dense. Cartilage, we'll go over the 3 types, and then bone, we're going to go over the structure of bone, and blood is kind of blood. But keep these 4 categories in mind. They're going to come back in play when we talk about certain characteristics of connective tissue. First, what we're going to do is we're going to talk about the functions, though. And obviously, one of the first functions of connective tissue would be to connect, so binding and support. We're also going to see it gives us some level of protection. Adipose tissue is a type of CT, so insulation. And a unique function is going to be transportation, and that's because blood is a CT. And one of the other things that we're going to talk about as it relates to the characteristics of CT is why is blood considered a connective tissue? It is an atypical connective tissue, atypical, one word. So it is not your typical type of CT. So why is it considered that? And what we're going to see is that it's because all CT arises from mesenchyme. So mesenchyme is going to be this embryonic CT, and we're going to get to that a little bit later. Other characteristics that we're going to see is that with epithelial tissue, it was avascular. Here, we run the whole spectrum. Cartilage is very, very poorly vascularized, whereas bone has a rich blood supply. So it runs the whole spectrum. The other thing that we're going to see with CT, if you remember, epithelial tissue had this high degree of cellularity, jam-packed full of cells. Here, we're really not going to see that, with the exception of adipose tissue, right? Adipose tissue, in lab, you'll see jam-packed full of adipocytes, jam-packed full of adipose cells. So here, all CT is going to have this ECM, extracellular matrix. So that ECM consists of the ground substance and fibers. So we're really going to see that there's going to be these 3 components to CT: ground substance, fibers, and cells. And that's kind of how we're going to approach this, taking a look at each of those. So first, we're just going to list them. So here we have this basic definition of ground substance, this unstructured material that fills the space between cells. Probably the best example is if you think of hyaline cartilage, that you're going to have these lacunae and the chondrocytes inside. And then everything in between, that purplish, that is just going to be this unstructured material. It is made up of some things, and we're going to talk about that. Fibers, the 3 fibers that we have to talk about that predominate in connective tissue are going to be collagen, elastic, or reticular fibers. And then the cells that we're going to talk about are going to be fibroblasts, chondroblasts, osteoblasts, and hematopoietic stem cells. Just as an FYI, hemopoietic or hematopoietic, same thing. So this AT is optional. So now what we're going to do, since we've identified those, is we're going to go and take a look at ground substance, then fibers, and then cells. So ground substance, we pretty much covered what it is. It has this interstitial fluid, and the rest of that unstructured material is really just going to be filled with proteins and proteoglycans. Proteoglycans are just protein plus carbohydrates. All right. So that is what ground substance is. We're not really going to get into the different types of proteoglycans and the different types of proteins, but suffice it to say, this combination is what will have that ground substance vary so much. Think of something like bone that's really, really hard. even something like cartilage that is a lot more flexible. The fibers that we're going to talk about, first we have collagen fibers, and what I want you to do is I want you to associate that if we need something to give us tensile strength, to resist pulling forces, and we need that high tensile strength, collagen is going to be found there. All right. Elastic fibers are made up of a protein called elastin. You don't have to know that, but it is coiled, and that's why it allows it to stretch. Now we have reticular fibers. These are a different type of collagen, how they're joined together. So they are collagen, but there's something like 13 different collagen fibers. So these reticular fibers are a type of collagen that will form these delicate networks. It's just going to be this soft skeleton, this stroma. And then if you think of the reticular tissue in lab, you had all of these fibers, and then you're going to have all of these cells hanging from it. All right, so those are the reticular tissues. All right, so now for the cells. If you remember our categories of connective tissue, we said there was CT proper, there was cartilage, bone, and blood. So for CT proper, the cells that we have are fibroblasts. For cartilage, the cells that we see are going to be called chondroblasts. Chondrocytes and chondroblasts, as an FYI right now, we're not going to really differentiate them. Blast, that suffix just means immature. And when we're talking about cartilage or bone, immature just means that they're more active. So the same thing with bone. We have osteoblasts. We can also have osteocytes. Not something that I'm really going to spend a lot of time differentiating between. In blood, we have these hemopoietic or hematopoietic stem cells that will give rise to blood. In 169, you'll learn that there are many different cells that make up blood. We have 5 different types of white blood cells. We have platelets, which are fragments of cells, and then we have red blood cells. And I wouldn't worry about this, the white blood cells, mast cells, any of that. I'll get to that later. All right, so now we're just going to start going over. After this, we've kind of talked about the characteristics of CT. Now we're just going to go over each of the individual types of connective tissue. And this should pretty much match your tissue examples that we've covered in lab. Normally, going over all of the different types of tissues would start a next section. I just want to cover this first one. We didn't take a look at this in lab, nor are we. We have this embryonic. So mesenchyme is just this generalized embryonic CT. And as that embryo develops, this mesenchyme will become more and more specialized. Some of it will give rise to bone. Some of it will give rise to blood. Some of it will give rise to CT proper, so on and so forth. So it's just this embryonic CT, and that's called mesenchyme. Okay? That's it for this part. Next part, we'll go over the individual types of CT.